Alright class, today I'm going to be giving a crash course on vectors. Now, before we get into what exactly a vector is, we must first talk about what a scalar is. A scalar quantity can be defined as a magnitude of a measurement, such as mass, speed, time, or distance. Now, you may be asking yourself, alright, why do I need to know what a scalar is to understand what a vector is? And that's because that a vector, many times, is an extension of a scalar. And a vector can be defined as a magnitude that is given a direction. So some examples of these, which you may have heard of, are velocity, weight, acceleration, and displacement. Now there's two ways you can represent vectors. First way is having your magnitude and then giving your direction. So some examples would be going 60 miles per hour going north, or going 60 miles per hour at an angle of 30 degrees. Now, we can write we can write what this part is as our vector, which many times is a letter. Let's say you're using velocity, you may want to use v, and then it's just a arrow going over it. Now, we can represent this on a coordinate plane. So we have our magnitude of our vector, and then we have our theta at the respect from the origin. And that can give us, that's the way we represent our vector on a coordinate plane. So let's say this is 10 meters per second. So it's 10 meters per second at an angle of 30 degrees. Now, the second way to represent a vector is unit vector notation, in which our vector will be equal to the x component plus its y component. So, and you may be asking yourself, all right, what are these two right here? Why is there an I and a j? And those are known as unit vectors, and they simply just represent the dimensions. So we use I for the x direction and j for the y direction. We also use k a lot, and that's used for like three-dimensional type things, but for now we're going to stick with x and y. So, going back to this, we know our vector is here. Our vector is going to be made up of these components. So this section here will be its y component, and this section here will be its x component. So, let's say, now that we know the representations for each, let's say we wanna switch in between them. Let's say we have our vector here, and we want to know its x and y components. We can use basic trigonometry for that. And in trigonometry, we know that the sine of an angle will be equal to the opposite over its hypotenuse, which in this case will be equal to the y component over our vector. And with cosine, which is the adjacent over the hypotenuse, which will be equal to our x component over our magnitude. And then just multiplying around and dividing, we can solve for the x and y components, and then we put it together like so. And I use c just for this example, just because I want to just use an arbitrary letter. It doesn't really have much meaning. You can use a or z or q. It doesn't really matter. So, let's do an example. Let me show you an example. Now, so we have RV as our velocity at 5 meters per second at an angle of 30 degrees. That's our vector. Now, we want to find its x and y components. Now, using trigonometry that I showed earlier, we know we can set up the problem as the sine of 30 is equal to v sub y over the magnitude of our velocity. And then that we know this is 5 meters per second. Remember to always include your units. We could then solve for the y component by using our trigonometry, the sine of 30 times by 5 meters per second, which is equal to about 2.5 meters per second. So, And then moving on, let's say we want to know what our x component is of this problem. We want to, of this problem. We want to know what this is. We just do the same, but with cosine instead of sine, which is equal to our adjacent over our hypotenuse, and then we can just find that 5 meters per second times the cosine of 30 degrees equal to x. And you can calculate this on your own, but I found that it was 4.33 meters per second. So now we know how to go from the magnitude of our vector defined as x and y components. So let's say we want to reverse. Let's say we had the x and y, and now we want to find this. We can use another math theory which you probably used before, which is the Pythagorean theorem, which states that in a triangle with a right angle, a squared plus b squared equals c squared. Sorry, forgot that. And so in context, let's say with that previous problem where I used c, we can find the magnitude of c, of our vector c, which is equal to the square root of the x component squared plus the y component squared. And then once we now that we have that, we can also solve for an angle. And in this case we'll use tangent, which in many cases we'll use tangent. You can also use sine and cosine, but for this case I would like to use tangent, which is our opposite over our adjacent, and then that'll be equal to the y component divided by the inverse tangent of the y component over the x component. And sorry I didn't have too much room here. I wanted to keep it all on the same page. So, all right, now that we know that, let's do another example. Let's do an example using the Pythagorean theorem. So, let's say we have, we're given a vector. Let's use c again. I like to use c, which is equal to, let's say, 5 meters in the I direction plus 4 meters in a j unit vector. Now, I know I used here, cx and cy, and these are just numerical representations of these. In this case, I just used 5 and 4. So if we want to solve for what our magnitude of c is, we can just do the square root of